So if you have not read lesson note number 16, this is all the way back in Algebra 2. Go ahead and take a minute to read that. And then if you have read it, go ahead and try these two problems here, number 1 and number 2. That's going to help us. The lesson for today is on conic sections and completing the square. And so we need to know how to do that first. Okay, so take a minute to try these or read the notes. Does anybody, so let's start with this first example here. I want to do both of these. This is going from standard form of a quadratic to vertex form of a quadratic using completing the square. And we need to know this because we're going to start doing conic sections today, and we're going to do completing the square of for circles to convert it to standard form. And so I'm going to make sure we feel completely comfortable with this concept. So as a reminder, what vertex form is. Vertex form is f of x equals a times x minus h squared plus k, right? Y'all can see my screen, right? As I'm ready? Okay, cool. So when we're completing the vertex form, we need it to look like that, okay? So our a is what for this first one here? What is the a of this? So what is the a of that standard?
Is it 1?
The a is 1 because the a is a number right in front there of the x squared. So we know that this is going to be 1, okay? Now, completing the square of the process, if you remember, what we need to do is we need to take the b, which in this case, the b is -4. And what we're going to do is we're going to take -4 and divide it by 2. And that's going to give us -2. And then with -2, you're going to square that. And that's going to give you 4. Okay, so the general pattern is you take the b, you divide it by 2, and then you square it. And that gives you the value that you add at the end. Okay, so let's talk about what we do with that for. And pause me at any point if you're confused. So we have f of x equals x squared minus 4x. And I like to leave a blank here because that blank is what we're going to complete the square with that makes it a perfect square. Now I'll put this plus 3. And I'm going to put another blank here. Okay. So what this is saying is we're looking at what is it that we add right here that would make this be able to be factored to a perfect square like that. So that number is always going to be this from the pattern, right? So right here we would put a plus 4. Hopefully it's coming back to us. And then because you added 4 in the equation in order to keep it balanced, over here we would need to put what?
-4.
-4. Because 4 minus 4 is 0, so we haven't changed the statement being true. It's still true. Okay. Now the reason for that is now we can go ahead and we can factor this. If you think about what number multiplies to 4 but adds up to -4, it's going to be -2 and -2, right? And so it would factor to x minus 2 times x minus 2, but then you can just write that as x minus 2 squared. So this process allows you to end up with that perfect square. And then you can go ahead and you can combine these two, which gives you -1. And so that is in vertex form. Okay, so that's a refresher on that. That's when the a is 1. When the a is not 1, you have one extra added step there, but any questions thus far? All right. So let's look at the one that a is not 1, so the one on the right. In that case, because your a, this a right here, is now 4, that 4 you know is going to be in front of the parentheses. So we're going to take that and divide the first 2 terms by 4 so that you get f of x equals, so that you get the 4 on the outside of that first set of parentheses. and then you'll end up with x squared minus 2x. And then you can bring that down. So we need to bring out the a, because this is the a, we need to bring it out in front of the parentheses. Then we follow a similar process. We're going to take the b, which now is a new b. It's now -2. Be careful not to use the old b, because we're completing the square of this. So we're going to take -2 divided by 2. That'll be -1. We're going to square it. That's going to give us 1. So 1 is a number that completes the square there. X squared minus 2x. And right here, we're going to put plus 1. And then we have -3. And then over here, you had to be careful. You're not going to put -1, because we didn't just add 1 to the equation. We added 4 to the equation, because if you think about it, when you distribute, 4 times 1 would give you 4. So you actually added 4 here, right? So you have to subtract 4 to keep it balanced with that. Then you would get, oh, that's a crayon. You would get f of x equals 4. You could factor this using factoring, or you could just look right here. This is always going to be the value. That's going to be squared. Okay. And then these two combined to give you -7. So that's in vertex form. Okay. So any questions on that part? That's a review back from Algebra 2, but this is a concept in which we will need for today's lesson. So I just want to make sure we're good with completing the square. We're going to, at the tail end of the class today, we're going to come back and use that for circles. So I'm going to pause and see if there are any questions. Before we get started on the new unit of conic sections, there's a couple of announcements that we need to talk about, and we'll have a brief discussion, okay? So let's talk calendar. If you have anything else, you can chat with me offline. You can send a message to me on Remind. So here's what we're in the 6 weeks. Usually I pass out the calendars physically, but obviously we're not together. And when I send out the 6 weeks calendar, usually it's bittersweet, because that means that it's the last 6 weeks with the class, and I don't like saying goodbye. But we are at the last 6 weeks. So here is and I've uploaded this onto Google Classroom, so that if you like to print and you want to know when's A day, when's B day, what topics are we doing, whatever. This is the tentative calendar as of now, and there's obviously potential changes that could be made. So here's this week. We're in conic sections and completing the square. That's today's lesson, okay? All the way through here, all of this is conic sections, okay? That's 1 unit. I'm going to stick to 3 lessons a week instead of 4. Sometimes 2 lessons a week. Okay. So if you look at this week, we have 3 lessons. That's just because of the Monday off, but still. Then Friday, Zoom office hours. Okay. Next week, Monday and Tuesday, we'll have a lesson. And then Wednesday, depending on how we do Monday, Tuesday, it would be a lesson, or it would just be a practice. Okay. So it might be 2 lessons that week. And then Friday, office hour. So that's the next couple of weeks. The following week, just 2 lessons. That's a new unit. Then Zoom office hours, and then you actually have another day off. I don't know if y'all know that, on May 1st. It's an inclement weather day. And then you have this week, I'm thinking of doing a full week, just because, so 4 lessons of being a full week, because your AP exams start here on the 11th all the way through the 20th. And I know that different people are taking different AP exams, and I want you to really focus on your AP exams and not learning new content. So really, we will be done with the pre-calc content by this day on the 7th, okay? So what that means is that we can just spend this 2 weeks. I want you to focus on AP exams. And what I'll do during that time is I kind of wrote down a list of the topics that's most important, that right when you get to AP calculus next year, what is going to be what you start off with? Things like the unit circle, trig identities, factoring, rational functions, different topics in which you will start the year off with. And so what I'll just do is I'll compile some review, and I'll just send that out, and we won't have a class session. I'll just send that out. It won't be a lot, so that you can work on those skills that for sure I can tell you are going to come up right when you start AB calculus in the fall. Okay. So that's kind of what the calendar looks like. So all of these topics, so this is 1 unit conic sections. This is another unit parametrics. Okay. That's the 2nd unit. These are not related to each other. and then we have polar, that is the third unit. All three of these, conic sections, parametrics, and polar, are all in BC calculus curriculum. They are not in AB. You're not going to see them come up next year in AB calculus. You're going to see them come up in BC calculus, just so you know, okay? So because we're kind of going to be doing stuff that you won't see immediately next year, you see the following year or in college level math, but it's still a part of the pre-calculus curriculum. That's why I want to make sure we review the stuff that's going to come up next year right away. Okay, so that's kind of what it looks like in terms of our calendar. And then ACP testing, like I said, there's no district ACP testing. So what that looks like, as soon as I find out, I will communicate that with y'all. Okay. Any questions about the calendar? And I posted this on Google Classroom, so you can see where we're headed. All right. So this week is going to be conic sections. No questions? Okay. We'll go ahead and get started then. As always, we say our 4 goals, even though it's virtual. We will learn math, build character, never give up, ask why. All right. So let's jump into it. These are conic sections. So there are 4 of them. There's a parabola, a hyperbola, an ellipse, and a circle, okay? These are visuals of conic sections. We're going to talk about them a little bit later. Couple of things to take note of. You already talked about parabola in Algebra 1 and Algebra 2, right? The new ones, kind of the big pieces here that we're going to focus on the next 2 weeks are hyperbola and ellipses, okay? Circle, you talked about that in geometry. We're going to touch on circles today. But these are the 4 conic sections. In your formula sheet, okay, there's a section in your formula sheet that says conic sections. And you have circle, parabola, ellipses, hyperbola, and you have the corresponding equations that go with them, right? You should be familiar with this formula. That is the equation for a circle, right? And then the parabola, we're not going to get to talk about these. These are kind of slightly different forms than we're used to, but we're not going to get to those here this semester. We're going to mainly focus on these right here. So in the next 2 weeks, we'll learn about the equations of a ellipse and the equation of a hyperbola. So just one thing to note, it is on your formula sheet there. Okay, so you will be referring to your formula sheet as we do problems tomorrow and in future classes. So you want to have that out, okay? Here's just a couple of applications of conic sections. We're not going to get to applications like we did with vectors, but just so you know some applications. If I can have one of y'all read each of these. So Kevin, can you read number 1? And then Carlos R, can you read number 2? And then Natalia, can you read number 3? And Jaira, can you read number 4? Emena, number 5. Brianna, number 6. Carla, number 7. And then Alexandra, number 8. So you can just go in that order. And you can just read these just so you know kind of application of these.
The paths of the planets around the sun are ellipses with the sun at one focus.
Thank you. And in that order, so Carlos R, number 2.
Parabolic mirrors are used to converge light beams at the focus of the parabola.
Parabolic microphones perform a similar function with sound waves.
Solar ovens are parabolic mirrors to converge light beams used for heating.
The parabola is used in the design of car headlights and in spotlights because it aids in concentrating the light beam.
The trajectory of objects thrown or shot near the Earth's surface follow a parabolic path.
Hyperbolas are used in a navigation system known as LORAN, long-range navigation. Hyperbolas are used in a navigation system known as LORAN, long-range navigation.
Oh, I'm muted. Number 8, I think I said Alexandra. I'm not sure. Maybe Alexandra, are you there? All right, I'll read it for her. Maybe she had to step out. Hyperbolic as well as parabolic mirrors and lenses are used in systems of telescopes. Okay, so these are just so you know some oh, mic doesn't work. I got you. I see it on the message. So these are some applications of conic sections. We're not going to get to applications like we did with vectors and like we will with parametrics. It was just so you know. We're going to stick with mathematical representations of them for the next couple weeks. Okay, so let's start with where they come from. Okay, we just talk about vocabulary. So they come from the relationship between a double nap cone and a plane, okay? So a double nap cone is when two cones are opposite of each other. So now we're in the notes. If you have access to the notes printed, then you can fill it out. If you don't, you can write this on a sheet of notebook paper. So a double nap cone is when two cones are opposite of each other. Can y'all see what I wrote? It looks like it's paused. The fill in the blank, is it filled in for y'all?
It's frozen. It just has the O and then a line.
Oh,
Oh, there it goes.
okay, there we go. Thank you. So what a double nap cone looks like is you have a cone. It's frozen still, isn't it? All right, so you have a cone, and then you have another cone opposite of it. And just to make sure we know what a cone, where a cone comes from. I'm trying to see if I can make a triangle out of this. Let's just say I took the sheet of paper. Okay, pretend this is a triangle, and I'll put this triangle on an axis. Okay, and I rotated that axis really fast, right? Can y'all see this? Looking at my screen. So if I rotate this really fast, that is what a cone. A cone is a triangle rotated around an axis that creates a cone, right? Okay, so we have, that's called a double nap cone. Okay, then you have a plane. A plane is a flat surface with no width, you could say, or no depth. Okay, so a plane is just a two-dimensional surface. Okay, so a conic section, circle, parabola, ellipse, hyperbola, comes from when you intersect this plane with this double nap cone. So if this intersects with this in a different way, depending on how they intersect, it will create a conic section of one of those four, okay? So just a couple of vocabulary we need to know about though. We have the base, okay? This is the base. It's gonna have two bases, right? The base at the bottom, base at the top. Then we have a slant height of the conic section, which is, this is the slant height. Okay. Then we have the vertex of the cone. That's the vertex. And then we have the axis of the double nap cone, which is like in the middle. That's that kind of the pencil that I had, that the cone is being rotated around. That's the symmetry axis. Okay, there's just some vocabulary about the double nap cone. So depending on how you intersect this plane with this double nap cone, it would create a different conic section, okay, in 3 dimensions, okay? So when you take a 2D plane and intersect it with a 3D. So these are the 4 conic sections: parabola, circle, ellipse, and hyperbola, okay? So I wanna, let's see how much time we have. We spent a lot of time on the discussion at the beginning. I wanted to do an exploration. Let's do a short exploration because I don't want to take too much of your time since we still have to do completing a square. So go on Google It's gonna be short. Usually in class we're gonna have a computer and we would kind of explore conic sections, but for the sake of time, I want to be respectful to your time. We're gonna do this just quick and just kind of mess around with it so you can kind of see what I'm talking about, and then I'll kind of give you the answer. So go on Google, and I'm gonna share my screen so you can see what I'm doing, and type conic section Explorer illuminations. Like on your computer, go on Google and type conic section Explorer illuminations. This right here.
Mr. T, we can't see your screen.
Gotcha. Let me. Okay, you can see it now.
Yeah.
Okay. So conic sections Explore illuminations. That's what you're searching on Google. Conic section Explore illuminations. And it's the first link. NCTM. And it takes you here. I believe this may not work on a phone. So if it doesn't work for you on a phone, you might have to just look on here, or if you don't have access to a computer. So what you have on this left side, can you all see my mouse as well?
Yeah.
Okay, cool. So what you have on this left side, if you kind of just click anywhere and you drag around, you can see you have a double nap cone. That's what's in red. And then you also have the plane, which is in blue. And depending on how this plane intersected it here in this way, it created, this is the graph that is formed from that. It created which conic section here? Which conic section is this? Is it a parabola? Is it a circle? Is it an ellipse? Or is it a hyperbola? Those are the four options if you look there on your notes.
Is it a parabola?
Yeah, it's a parabola. It's sideways, so it's not a function, but it's still a parabola. So what I would like for you to do is, if you look at the bottom here, you can change the parameters. So if you change the height, that changes how tall the cone is. And you can click this reset button right here and it resets to their standard position. If you change this M, that changes the slope of the plane. And then you can kind of see what's happening over here. If you change this B, that moves it up and down. So kind of just play with that for a little bit and just see how can you create the four conic sections, okay? So like moving it, how could you create the four conic sections? So try moving this around and looking at what it does to the graph, kind of changing the height and just messing around with it a little bit, okay? So I'll give you a second to do that. And then I'm gonna go back to my,
Yeah.
okay, awesome. So here's just wanted you to mess with that for a little bit. So here's kind of what they would look like in general. So you can take a minute to fill that out. These are just one example of each conic section. So for the parabola, as we discussed at the beginning, the plane has to intersect it, and it has to only intersect one of the cones. And if you notice, it has to hit the slant height, and it also has to hit the base. And that will create the parabola there. That's the parabola. So it has to hit the slant, and it also has to hit the base. For the circle, it can only pass through, so I'm gonna write, this one passes through one. Passes through one cone. Oh, that does not look that one. So on the first one, it passes through one cone. This one also passes through one cone. And this one has to pass directly horizontal, right, to create a circle. That's the circle here. For the ellipse, it also passes through only one cone, and it has to hit both of the slant heights, but it has to be slightly slanted. That's a lot of slants. It has to be slanted and hit both of the slant heights. Okay. For the hyperbola, it passes through both cones, and that's going to give you the hyperbola. So that's just a visual of the conic sections. Okay. I'll give you a minute to write that down. And if you're kind of having trouble with the drawing, like you can just draw like that, and then you can just draw. For me, I just do like that, something like that. So a few more seconds there. Okay, cool. So that's the conic sections. That's just kind of overview of why they look the way they do. There's kind of special conics called degenerate conics. Is like if you want to just create a point, it would have to only pass through the vertex. If you wanted to create a line, it would only pass through the slant height. And if you wanted to create intersecting lines, it would have to pass through both slant heights. Okay, for the purposes of what we're about to talk about, you don't need to necessarily know that, but just so you know, those are going to be special cases. Okay. All right. So here's just another visual if the other visual was hard for you to see. This is how you create a parabola, passes through one of them, circle directly horizontally, passes through one, cone, ellipse, slanted, hyperbola, passes through two, okay? So that's just another visual if you had a hard time seeing with all the colors going on, okay? All right, so let's just do 3 of these and then we'll talk about circles completing the square. So we'll do the first one together. So the question says, if a plane intersects a double nap cone parallel to the slant height of the cone, what type of conic section is formed? Okay. So the first thing we want to do is draw the double nap cone. So that's kind of how I draw the double nap cone. And it says it is parallel, which means it never crosses the slant height. So this is the slant height. I can use either slant height, but let's just say I use this slant height. Okay, so I'm going to use that slant height. And it says it is parallel to that, meaning it doesn't cross that. So if it is parallel, then I can draw the plane on either side works, but let's say I draw it over here. So then what conic section would that form? Is what we're looking at. Would it create a parabola, a hyperbola, ellipse, or a circle?
A parabola.
Yeah, it would create a parabola because it would be like this. Well, let me do it in a different color. This would be the parabola here, right? Passes through one, it's slanted, that's a parabola, okay? So that's kind of how you would just generally know what the conic section is. So y'all try these 2 right here, okay? I'll give you some time to try them. So it's perpendicular to the base of the cone, so it's not crosses at a 90-degree angle. Parallel to the symmetry axis, meaning it doesn't cross. So it would be like that, something like that, which would create a hyperbola. because it crosses both of the naps of the cone. Okay. The second one, it says it intersects only one nap, so it only hits one of the cones, the top or the bottom, and it passes through both the slant of the cone. So let's just say I'm only going to use the top part of the cone. So it passes through the slant and it passes through the base. So it has to cross both the slant and the base. So it'd be crossing both of them, so something like that. So since it touches the base, that's going to create a parabola, because this is a parabola right here. So some of y'all were saying ellipse. In order for it to be an ellipse, it can't touch the base. It would have to be like slanted, not touching the base, so that you can get that full kind of rounded off on both sides. Okay. All right. So that's conic sections from an overview perspective of kind of how they relate to the cones. We're going to just talk about circles completing the square, and then we'll call it a day for today. So today we're just focusing on circle, that equation, which you should be familiar with, but we're just talking about how to get it in that form. Ellipses, we're going to talk about ellipses next 2 days, and then hyperbolas next week, okay? So this is the formula for a circle. And what we're looking at, just a reminder, the H and the K is the center. H and K is the center. The R here is the radius. And you have to be careful because it's R squared. So like if this equaled 25, your radius is not 25, your radius would be 5, because 5 squared is 25. So that's just the kind of key parts of the formula there. So what we're looking at is just, what if you had it in this form? That's your equation. And you wanted to write that in standard form. This is still the equation of a circle. Okay? It's just not written like this. I'm not sure if you touched on completing the square in geometry or not, how to get it from this form to this form. If you did, then it's a review. If not, then it's something new. I see you shaking your head, Maria, so I guess not. You didn't do that? No? Okay. So when we're wanting to get this to this form, we're going to complete the square. Okay? So first we need to make sure it's written in order. So you have your x's and then your y's. Okay? So what we're going to do is let's actually move, actually we'll leave it there, it's fine. So what we need to do is, first we're going to focus on just the x here. I'm going to separate this. So I'm going to put a parentheses over this in green. I'm going to put a parentheses over this in y. And so we're going to complete the square of the x kind of side of the formula, complete the square of the y part of the formula, and then end up making it into 2 perfect squares. Okay? So let's start with the x. So we're going to have x squared minus 2x. And we're trying to figure out what can we add right here. Okay? So in other words, what can we add right here that will make this whole thing factor to this perfect square? Okay? And then over here, we're going to find out, okay, what can we add right here that will make this whole thing factor to this perfect square? So how can we complete that square? We still got this minus 4 equals 0. All right. Now, I'm going to go ahead and move this 4 over because we don't need this 4. I'm going to add the 4 to the other side, okay? So I'm going to move the 4 over. So I'm just going to go ahead and erase this and make it equals 4. Okay? So I just moved the 4 over. All right. So we're going to follow the same pattern that we usually do when completing the square. So this is our b. So we're going to take that -2. We're going to divide it by 2. That's going to be -1. We're going to square that, which is going to give us 1. So 1 is the number that completes the square. So 1 is what we're going to add right here. That was what's going to complete the square. And since we added 1, we can't just change the whole equation. We need to keep it balanced. So since we added 1 over here, instead of subtracting 1 over here, we can go ahead and add 1 on the other side of the equation. Because this is the equal sign, right? So if you add 1 on one side, you add 1 on the other side of the equal sign so that it's still balanced. We'll leave that as +1 for now. I'm gonna go ahead and complete the square of the y as well. So same thing for y. I'm gonna take the b of the y, part of the equation, so that's -4 divided by 2. That'll be -2. We're gonna square that, it's gonna give us 4. So 4 is what we need to add right here to complete the square. And in order to keep it balanced, we also want to add 4 over here. So we haven't changed the fact that the left side equals the right side. The left side still equals the right side because we're balancing it out on both sides. We're just manipulating and doing some algebra to make it become in standard form. So now this can now be factored to that perfect square, that first perfect square. And what would that factor to? You can think about it as what two numbers multiply to 1 and add up to -2, or you can look back over here, right? So what would that factor to? Say that again?
-1.
Yeah, x minus 1 squared, yeah. We can get that from right here, or we can just look at what two numbers multiply to 1 and add up to -2. And then this one over here will factor to y minus 2 squared. And then you would add all these up. 4 plus 1 plus 4 would be 9. And this is now in standard form. So that's how you get it to standard form when it is kind of foiled out. And you can work backwards to get this to look like that. If you went ahead and you kind of wrote this out. Wait, that's -1, sorry. You did plus, you wrote that out twice. You kind of distributed all of this, you distributed all this, you would end up with that, right? It's expanded out to give you that form up there, okay? So you could check your answer in that way. You could FOIL your answer out and simplify it, and it would give you your original. Another way you could check it is you could graph this, and you can graph this, and they would be equivalent. They will both be circles at the same circle. And so just make sure we know our vocabulary. So our center of the circle would be, remember, center is H and K. You already have a minus here. The minus is not a part of the H, so the H is 1. H. K is 2. And the radius, since this is already squared, we're looking at what squared gave you 9. Or in other words, you could take the square root of that. So the radius would be 3, right? All right, any questions on completing the square to convert to standard form of a circle? I lose anybody at any stage of that? We'll do one more together to make sure that where there's a where you have to divide. So any questions? Okay, let's do one more. Converting to standard form. So this is an example where you have a number other than 1 in front, okay? So let's say we want to do that. We're going to do it similarly to how we did at the beginning when we kind of review completing the square, where you would divide, except you wouldn't just divide the first 2 terms, you would divide everything. So we're going to divide everything by 2. Okay? So it's going to be, and because we divide all of them by 2, including on the other side of the equal sign, because you're keeping it balanced like that, you don't need to keep the 2 on the outside because you're not factoring the 2 out. You're dividing all of them by 2 all across the board. So that's an important distinction there. Because when we were doing like with quadratics, you factored the 2 out like this, right? And you kept it. But we're not doing that here. We're dividing all across the board. It's similar to like adding on the left side and adding on the right side. You're keeping it balanced, okay? So we're not going to keep the 2. Why do we not want to keep the 2? Because if we keep the 2, we wouldn't do it on this side. And then you would have a 2 out here, but you never have a 2 out here when you're talking about circles. So we divide all the way across the equal sign. So it's x squared minus 4x plus y squared plus 6y plus 7 equals 0. Well, this was divided by 2, but 0 divided by 2 is just 0. So you divide all the way across the equal sign. Then I'm gonna go ahead and move this 7 over. So I'm gonna change this to -7 right here. I'm gonna erase this. We're gonna follow the same process. I'm gonna complete the square and separate the x's. Separate the y's. We're gonna complete the square. So we're gonna take the b, which is -4, divided by 2. -2, square that, it's gonna be 4. So it'd be x squared minus 4x. Right here we put plus 4. And we also need to add 4 on the other side. And then same thing here, we have the 6. 6 divided by 2 would be 3. We're gonna square that, it's gonna be 9. So that means we're gonna have plus 9 here. We're gonna add the 9 on the other side as well. So we add these, it's gonna be 13 minus 7, 8. And then the last step, you just go ahead and complete this square. So this would factor to x minus 2 squared, and this one would factor to y plus 3 squared equals 8. And that is in standard form of a circle. Any questions? Did I lose anyone anywhere?
Mister, would it be 6 instead of 8?
Yes, it would be 6 instead of 8. Thank you. Right here, right?
Yeah.
Yeah, my bad. You're right. So if you're finding the radius, you would leave it as a radical, by the way. You could just say it's the square root of 6, right, for the radius. That's okay. Because it's a decimal, what squared gives you 6. Okay, so that's how you convert by completing the square. If there are no questions, just talk about what the practice is. So tomorrow we'll do ellipses, 10 o'clock class. Your practice is just over converting. We'll do IXL, V.5, just 1. That's in geometry. So this is geometry, V.5, that's just convert what we just did, how to convert circles from general to standard form, okay? And that's due on Friday, as all practice I've been doing on Friday. What else? Oh, Senda, I want to do a habit of doing this since I can't get, since I'm not able to see as much or get feedback as much on like how you're learning. Send a message at the end of the group, or sorry, in the group chat of 1 through 10, 10 being you understood the lesson conic sections and completing the square for circle, 10 being you feel comfortable with it, you feel like you can do it on your own well, 1 being you're terrible at it, you don't get it at all. 1 through 10, send it in the chat. Okay. All right, so we're looking at, see, 8, 9, and 10, okay. In closing, it's up to you. You can, I like your answer, Jair. Can you write that in radical form, Jair? In closing, you can stay if you want. If you need to go, you can go. I want to be respectful of your time because that was an hour 30. We spent a lot of time at the beginning kind of talking about logistics stuff for the 6 weeks and grading and stuff like that. Be encouraged, continue to learn. And if you want to stay on to do these problems, you can. This is just if you feel like you want. These are 2 SAT problems from about circles that I just pulled up just to show you how it could come up on the SAT. So if you want to do them, you can stay on. If you need to go, you can also go. I'll just stay for those who want to try one more practice. You can try these and I'll give you the answer after. So it's up to you. If you're going to go, peace, have a good day. If you're going to stay, you can work on these problems if you want to. Okay. So I'll stay on for a little bit.